Hi, this is Matt with LSAT Cracked. In a previous lesson, we discussed quantifiers, specific words with specific definitions. In this lesson, we're going to make sure you feel comfortable knowing how to take that quantifier that you see on an LSAT stimulus or in an answer choice and convert it to a diagram that you can use on your scratch paper. This is going to be especially important for some of the templates, the transitive templates that we're going to be looking at in a little bit. Let's start with something you already know how to diagram, an all statement. Why do you know how to diagram that? Because it's exactly the same as an if-then statement. If I say all apples are fruits or all dogs are mammals, it's the exact same thing as saying if it's a dog, then it's a mammal. So you already know how to diagram that. It's a pure arrow statement. D, arrow, M, with nothing underneath the arrow. It's just a pure arrow. Now let's take it down one step to a most statement. If I say that most dogs are friendly, let's think about how we would diagram that. I'm saying that with the object class of dogs, most of them I can conclude are friendly. So you want to do that as D, arrow, with the word most or a little M underneath it, F for friendly. The reason you're using an arrow is to remind yourself that the directionality of the most claim only moves in one direction. If I were to establish that a given animal or object outside was friendly, you wouldn't be able to say there's a greater than 50% chance that it's a dog. You're only able to say if it's a dog, now you say 51% or more of the time it's going to be friendly. So the directionality of a most claim only moves in one direction. You cannot reverse a most claim. We'll talk about that in a little bit. With a sum statement, no arrow is needed. A sum statement is simply a claim that two things overlap at least once. So if I say some apples are rotten, I'm not saying all apples are rotten. I'm not saying most apples are rotten. All I'm saying is there's at least one A apple that's also an R, rotten. A, some, with a line over it if you want, but no arrow. R for rotten. The key difference is a sum claim can be reversed. Lastly, we've got a none claim or a no claim. If I say that no butterflies are mean, that simply is an all claim with a negation at the end of it. It's simply saying if butterfly, if B, arrow, M, not mean. And for some extra credit, I referred in the last lesson to the idea that a not all claim is really just a sum claim in disguise. If I say that not all parrots are intelligent, all I'm really saying is that some parrots, P, some, are not intelligent. I with a line through. P, some, not I. And again, because some claims are reversible, it could be written as not I, some P. With the ability to crisply diagram each of these quantifiers, you are going to be well positioned for the next exercise, which involves us discussing when two or more quantifiers can be combined successfully or unsuccessfully in a transitive template.